Okay, let me get this fixed. Okay. This 1 point. Damn it. I printed y'all's like the new schedules and accidentally left them on the printer. So I'll bring them Thursday. Everything just kind of got shifted like a day and we lost the review day was what ended up happening. You should recognize it. All I did was just print it from last semester. It's the exact same one. As I was looking at my notes, because everything just kind of wanted setups, and then it's the 4, 5, 6, 7. Everything else is like where we actually have to solve it. I think I literally used the exact same numbers from the homework. Like there's a problem in here that's just going to give you the answer for one of the homework problems. Like, just how it ended up working out. How charged are you? All the way charged. Okay, y'all, it's 8. I know that there was some of y'all that weren't able to be here for like 1.4. I have the whiteboard link that I could send y'all, or if y'all have any questions. Today's the day that from like 12:15 to 1:30, I just stay in here after my classes. So y'all could come and ask me questions, or y'all could email me if you have them. On the board, I wrote the new exam 1 dates for my classes. Y'all are 13-14 for college algebra, and it's actually next week on Monday. So today we're doing 1.5, which means on Wednesday we'll do 1.6, and then on Monday we'll just take the exam. Okay, so the quicker I can get done with 1.6, like I could answer questions, and I'll send y'all a review tomorrow for the exam 1. Okay. So 1.5, I copied and pasted this basically from last semester. I looked at the homework. There was like 2 problems that were different. So I believe I like removed them from the homework. So if it tells you that you've received all credit and I've removed the problems, just don't worry about those. And then if y'all see something on the homework that isn't kind of in this like random little pass out, y'all just tell me so I can explain it to y'all, or I'll delete that one if I can. If it ends up being something I don't have to test you on, I have no problem deleting things. Okay, so for 1.5, it's applications and modeling of quadratic equations. The first page of this pass out, you'll notice on the homework, they don't really want you to solve the problems. They just ask like what equation would be used to solve it. And so I'm just going to show you like the way that you would actually just format the equation. And then like usually you're either going to select like A, B, C, D, or E, or you'll type it out. Okay, it's the other pages 2 through 4 where there actually is like a lot of different things that we'll need to solve. But for problem 1, it says for a rectangular discount shoe store shown, what is the equation if the area is 50,000 yards squared? So the actual formula that we would use for that rectangle would be area equals length times width. And the 2 different like values that they gave you, one of them is the length. And then the other one is going to be the actual width. And we're just going to multiply those together. It tells me right here, hold on, because I haven't really messed with this thickness or anything. It tells me that the area equals 50,000 yards squared. And so I would just write that first, equals, and then length times width. I could use this one for the length, and then it's going to be times the width. So you could either use a multiplication symbol. I think they might use parentheses. But if we use the simple X for our width and then the other value as our length, it's saying on the right-hand side of the equal sign, when you multiply the length times the width, it equals the area. And they told me right there, that's what the area is. Like they just kind of want you to put it into an equation, then you select the correct one. Okay, they don't actually want you to solve it, okay? And there's a lot of problems like that on the homework that just want it arranged in a specific order, but not solved. So if it does confuse you or anything, y'all just like do that ask my instructor. I assume if one person has an issue with it, more than one do, so just let me know. Okay, for the second one, it does tell us to use the Pythagorean theorem. And it actually will give us a form of it. It is actually a squared plus b squared equals c squared. And if you notice, it's exactly the way they have it written here, but they have the c squared in the front. They just wrote it slightly different, but they want us to arrange it in that way. So pay attention to how they have the certain things arranged. Your a squared is going to, or not your a squared, I'm sorry, your a is going to be the simplest, which I got to change the thickness, which is going to be just the simple x right here. And then for your b, I always do, and that's supposed to be a right triangle also. For your b, I always just do the one that's directly next to it. And then for your c, that side is going to be the actual longer part of the triangle, which would be, it's actually called a hypotenuse. But again, they're not even having us really solve these. So it's just like declare them and then put them into the formula or like the little equation, and then that's it. So if we have it set up like that, I always go A, B, C. If you look at the way they want us to just kind of format everything, our C is the 5x plus 11, and it's telling me it's going to be squared. So I would put the 5x plus 11 inside of parentheses and square it, equals, and then it says a squared. My a is actually just an x. So I do x squared. Then it says to add to that your b being squared. My b is 5x plus 1. So in parentheses, I would put the 5x plus 1. Then I would square it. And so I remember on this homework problem, excuse me, it has like A, B, C, D parts, and it has all of these different types of values. Some of them might all be squared, and one it's not going to be squared. And then you just kind of see how they want you to arrange it. And then if you write it on your piece of paper, it should match exactly what you see on the homework. But again, this is another one where it doesn't want you to solve. It literally is just asking you like which equation would be used. Okay, so that ends up being it for that problem as well. On first page, very bottom, problem 3, there's kind of a problem that you would see in like an introductory like type of like physics class. And it talks about a projectile being launched vertically, and it's going to actually ask us, there you go. He's like, hold on a minute, she ain't writing nothing. Sorry, I should have said that when you walked in, babe. So it's going to actually ask, it's just like that. I have it up here on the board if you want to see it. It's going to actually just ask us, like you just can read through the problem itself. Then it's going to ask us what like equation would actually be used. And so we're just going to like basically write it out and then select the correct one. Okay. They don't ask us any other questions as far as like solving them on a lot of them. And so here are those examples. It says for a projectile, I don't even make English sense. Okay, a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance. This is the only part that matters right here. It says its height, s in feet. Okay, it's actually declaring and like kind of telling me what one of these variables mean. Above the ground, t seconds after the projection. So t is seconds, so t is time, s is your height, right? It's actually like kind of letting you know what these variables are, so you know what you need to replace when it asks you what is the equation that would be used. It says is given by s equals negative 16 t squared plus 100 t. Okay, and it kind of says it again, where t represents the number of seconds after it's been projected. And it says, what is the equation needed? That's all it wants, is the equation needed. When you look at part A, it says, what is the equation used for how many seconds will it be 50 feet above the ground? Okay, so it's telling me height, 50 feet. Okay, it wants to know what the seconds would be, which would mean if t represents seconds, that's going to be what stays as a variable in that equation. And it's not going to be plugged in for something. Because if we did have to solve it, we're trying to solve for t, right? Because it gave me an actual numerical value of 50 feet, that's height above the ground, right? And whenever I looked in the actual problem, my height is being represented by s. So this right here, I'm gonna just highlight it in yellow again. That right there, that's the little formula. And it wants me to actually specifically state what equation I would use if I'm talking about 50 feet above the ground. This formula right here has two variables, so we're gonna replace one of them. It has an S and it has a T, right? 50 feet is height, that's not time, so that's gonna actually be what we write for our S equal negative 16 T squared plus 100 T. And that's it. That it just wants to know what equation would we use. Now, in an actual physics class, you have to answer all of this and then get your seconds. It'll say how long before it reaches the ground, or it'll give you all different kinds of examples. Here, I replaced the S with the 50 because it asked me 50 feet above and it told me S means feet. It was height. Okay. And so that right there would be how you solve it, or like actually answer that question. You don't have to go a step further and actually solve it. Okay. Now we are going to get into the problems where there's lots of solving. These right here are going to be word problems, and we actually need to like pay attention to like math word problems. Like the product means that you're multiplying things. Is another word for equal. Okay, so integers are going to be like your counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, and they just go on and on forever. Those would be consecutive, because it's you go to 1, and then you go to 2, and then 3, and then 4. They're like one after another. In these problems, they'll specifically say something like even integers. Your even integers are just 2, 4, 6, 8, 10, 12, right? I'm not including any of the odds. For it to be even and consecutive, 2 and 4 would be even, and they're consecutive because they're like the one right after the other. 2 and 6, even though those are even integers, they're not consecutive, like they're not one after another. Okay, so you kind of have to pay attention to all these different words. Whenever it says the product, we're going to be multiplying two numbers that are even consecutive integers. And then whenever it says is, that means equal, and it wants us to find these numbers. Okay, so this is how I've always just kind of started these problems. We need to because right now we don't know either of these numbers, right? What we're doing is we're creating an equation so we can solve it. And then we know what these two even numbers are that are one after another. And when we multiply them together, they end up equaling 288, right? So if I'm creating a formula or like an equation, I'm going to let one integer be x. That's one of them. It's the simplest thing to start with, and it's what you would always start with. Now, if it said, y'all don't write this, but if it said just if it just said consecutive integers, right? 1 to 2, 2 to 3, 3 to 4, then I would take this first one and I would just be adding 1 to it, right? Because it's just the next one. But it didn't say consecutive integers. It said consecutive even integers. So if I have this one random number that I don't know what it is, but I know it's even, the way I would get to the next even integer wouldn't be to add 1, it would be to add 2, right? So if my one integer that's unknown that I don't know what it is x, then the other consecutive even integer is going to be represented by x plus 2, like that whole little expression. Okay, so let's just kind of write that, and then let's see, we're going to say, oh, let this be x, and the other x plus 2. And to my knowledge, on the homework and even on the exam, it's going to be the same one. It's not going to say next odd integer or just next integer. It's going to be consecutive even. Let one be x, always let the other one be x plus 2, right? And then the key word here, honestly, y'all, is the product of. Product means I'm going to be multiplying things together, right? So if I take this first unknown integer, which is x, it's telling me I'm going to multiply it to this other unknown integer, And then it says that it's gonna equal 288, right? So if I take this first, what did I do? Am I black? Yes. If I take this is what I'm gonna do. I'm gonna take this first integer that I have. I'm gonna do the product of both of them, which means to multiply. And it tells me the product of two consecutive even integers is, that means equals 288. If I'm not mistaken, because I always try not to be a liar, the 288, that's what changes on an exam problem and on your homework problem. And just to be completely honest with you, y'all might actually say on the homework 288. Okay, if it does, maybe do another example so you get practice, but I think this might be the exact same one that comes off of your homework. So on the test, this is going to be copied, it's going to be pasted, and now it's going to say a different number other than 288. The setup's the same. Okay, it's x times x plus 2 equal whatever number it says. Okay, and then what sucks about these, I'm not even gonna lie to y'all, is that there's going to be foiling, and then there's going to be like where we're going to do that shortcut method to like factor it, but we're going to be factoring this big number, this 288, until we figure out what two numbers multiply to give you C and then combine to give you B. You know what I mean? It's the same stuff that we did a minute ago, but now this number is much larger than what we have seen before. Okay, so this is the setup. This is like the way you would actually start this problem. And now what we're going to do is, because it wants me to find the integers, I actually need to figure out what both of them are. Okay, so I'm going to FOIL here first. I said FOIL. I don't know why the heck I said that. It's Monday. I'm going to distribute here first. I'm going to do x times x, which is x squared. And then I'm going to do x times 2, which is 2x. They're both positive, so their product is positive. And then I have, I'm going to do it the long way. I have equals 288. Now, in order for me to actually solve this, my hope is that you understand that since this x is squared and I'm looking for two integers, that this is like a quadratic and it needs to be set up in that certain way. So I actually need to take that 288 and I need to move it, right? Instead of it being on the right-hand side, I need to move it to the left-hand side of the equal. It's positive on one side. So whenever I move it, it's actually going to end up being negative right here. And now that I have it set up in that ax plus bx plus c form, I can actually solve this now. And so here, I can write this right here, y'all, look, minus 288, and then like minus 288, right? That was the step I just did there, so that I could get it in the actual proper form of a quadratic. I know it's a quadratic because of that squared term in the front. It's the highest one. It's the biggest one. Okay. Now, I'm not even gonna lie. If y'all wanted to do the quadratic formula, you could do that. But you have this other option that we learned, because this value right here, the A is a 1. I could do that shortcut. Okay. And it really just depends on which one you understand more and which one you prefer. But the shortcut says that I could create these two parentheses, have them equal to 0 in the front of the parentheses, or like the first place value of these parentheses. It'll be the variable I'm working with. And then right here goes the two numbers that multiply together to give me my C, and then combine together to give me my B, right? I'm gonna tell you right now, I don't even know what those factors are off the top of my head, because that's a huge number, right? If it's a 24 or 12 or 36, you could usually kind of do it in your head. Whenever it's a number like this in the 3 digits, what you want to do is kind of go to the side and start factoring it to look at what numbers multiply to give you 288. And so if I come right here and I do 288, you could do like a factor tree. I know for a fact 1 times 288, that equals 288. And if y'all grabbed your calculator, that'd be fine, but you don't have to, okay? If I divided it by 2, right, I'm going to get 144. Okay. And I actually don't have all of them written on my paper, so let me just see, because I skip things a lot. After doing it, you just kind of know things. Okay, then I grab my calculator, I divide it by 3, and I get 96. I'm looking at these factors, I'm like, okay, yes, those multiply to give me 288, but there's no way in the world, if I added or subtracted those in any way, shape, or form, they're gonna give me 2. So that kind of tells me like, hey, it's gonna be like, I need to keep doing that division for a while. It's gonna be like a larger set of numbers. It's not gonna be these little ones so far that I'm working with on the left-hand side. And so I kind of just skipped and I divided it by 9. And I got 9 and 32. And then y'all, if you did 288 divided by 10 in your calculator, you don't get a whole number. I get like 28.8. That does not go here. Okay, because I want actual whole factors. I don't want to deal with decimals or anything right here. So then I take 288 and I divide it by 11. That's a decimal. I keep going. 288 divided by 12, I get 24. So I have 12 and 24. Okay, and then I keep going on my calculator, divide it by 13, divide it by 14. I keep getting decimals over and over again. Then I finally divide it by 16, and I get that 16 times 18, right? When I multiply them, it equals 288. Now, whenever I combine those together, I'm trying to get to a positive 2. Right? So you would want the larger one to be positive, and it looks like the smaller one's going to be negative because I need to have their product equal a negative. And I know negative times a positive is negative, right? So if I know that, what I 16 and 18, those have to multiply to give me a negative, but I want them to combine to give me a positive. So I want the bigger one to be positive. I want the smaller one to be negative. And I just now created the linear factors that came from this quadratic equation right here. Now what I do, because I have factors set equal to 0, I use that 0 factor property and I set them both equal to 0. I'm going to go up just a little bit like that, y'all. Okay, I'm going to have, stop. I have this one set equal to 0, and I have this one set equal to 0. Isaac, for this one right here, if I move that 16, what's this x equal? Right, so there's 1. I don't want to square it because it's going to mess up that whole other little problem there. Right there. That's one of, what's it called? That's one of my factors. This 16 is going to be paired with another number. And then this right here, when I solve it, don't I get a negative 18? Okay, this is also one of them. Now, the only thing that I kind of think is super confusing, because if you can get this part down of factoring it, what multiplies and what combines, and kind of solve those little bitty equations, what it wants you to do is to like plug them in individually to find the other one that goes with it. Okay, so like the x equals 16, the other one that would go with it is actually just going to be a positive 18. And then with this x equals negative 18, the one that's going to go with that, let me just show you. Let me see. Let's do this. Let's say now, thank you. Now, if x equals 16, so I'm looking at that very first little bitty equation that I solved, right? If I remember what I wrote right here, one integer is x, let the other one be x plus 2, right? So what's 16 plus 2? 18. So x plus 2 would be 16 plus 2, which would be 18. Okay, so the two consecutive even integers whose product is 288 is 16 and 18. And then do you see right here, we had this other one of negative 18. So do the same thing. use the fact that if one of these is -18, say I add 2, what would it be then? Okay, so we have and if x equals -18 and we do x plus 2, we would be doing -18 plus 2, which is -16. And those are, even though they're negative, they're both even, they're consecutive. And if I multiply two negatives together, a negative times a negative is going to be a positive, and 16 and 18 is 288. So it's kind of just giving you the 16 and 18. Usually a lot of students will tell me the 16 and the 18. And you just have to make sure that you also account for the fact that like their negative counterparts when multiplied together will still give you that same product. Okay. So if y'all have any questions about that on your homework, y'all just let me know. But like I already told y'all on the exam, it's going to be even consecutive. The number that's going to change is that 288. Okay, you let one be an x, one be an x squared, set it up in the exact same way, distribute it, move it, factor it. Set up these little bitty equations and then tell me what there's going to be 4 total numbers. Okay. Okay. So now let's do the other one. Y'all can put an asterisk there if you need to. I would definitely on the homework, if you see 288, enter it in the way it wants it, and then do another similar example. Okay, try to do the same steps with a different number, just so that y'all have that practice. Okay, okay. So for this one right here, I'm trying to remember because there was a typo on this last semester. I got here at like 5 o'clock in the morning, so I'm kind of tired. One leg. Hopefully it's okay now. So this one says one leg of a right triangle. Okay, what's missing is an actual drawing that they're not going to give you. So I'm going to go ahead and on my piece of paper, I'm going to draw a little right triangle so that I can solve this problem. It says one leg is 3 meters. The other sides have lengths that are consecutive integers, not consecutive even, right? But just consecutive integers. So if we have one of the legs being 3 meters, and this one's always been hard because of it's okay. I'm gonna use X because I'm used to always using X. Okay, and then it says that the other ones have consecutive integers for their lengths. I know that the hypotenuse, which y'all, that's like the slanted one, that's always going to be the larger one. So I always go like A, B, C. They give me 1. These are going to be the consecutive ones. If it said consecutive even, the number that would go there would be 2, right? But it didn't say consecutive even. It just said consecutive. So I'm just going to actually have to do X plus 1. And it wants me to solve for the other 2 legs of the triangle. So because it's talking about a right triangle, we are going to use a squared plus b squared equals c squared, and we will be able to solve for them. Because it's going to be very similar to the previous problem, and we're using all these like quadratics, that's what 1.5 is all about, quadratics and real life problems. We're going to end up having to find 2 different values. On this type of problem, if you have an answer that's negative and it's length, you can't have negative length. So the answer ends up just being the positive one. Okay, so if we do this, where's my markers? Okay, what I'm going to do is I'm going to have my A equal my 3, my B equal my X, and then my C is going to be the X plus 1. That way I can use these values that I have written in black around this right triangle to plug into the formula and then be able to solve. So it starts with A squared, and what I have for my A is 3. And so I'm going to write right here, 3 squared plus B squared. My B, that's one of my unknowns. That's why it's being represented by X. And so I just have X squared right there. Then I have my equal sign, and then my C is always my hypotenuse, which is always that slanted line because it's the bigger measurement, and it is X plus 1. Well, it's telling me that my C is being squared. So I need to actually put the whole thing inside of parentheses and then square it. And then now I actually kind of have it set up to where I can do foiling for my c squared on the right-hand side, figure out what that is. I need to move some things around, and then I'll be able to actually kind of solve this. Okay, so y'all, 3 squared is just a numerical value being squared. 3 times 3 is 9. Plus x squared is just x squared, because I like have nothing to plug into it or anything right now, right? On the right-hand side, if you ever see parentheses with a binomial, meaning 2 things on the inside, and then it's being squared, it's just telling you to make a copy of the parentheses that many times. So that 2 is telling me to make 2 copies of what I see inside of the parentheses. When it has the exponent, it's what we call like condensed, because we're trying to make it like simpler. And then if you like apply that squared, you're gonna like expand it and you make it more complicated. But this way you could actually solve it. 2 binomials in parentheses touching means that we're gonna FOIL. Okay, and FOIL is the first ones being multiplied, the outside ones, the inside ones, and then the last ones, that whole little process. Okay. So left-hand side, I have 9 plus x squared equals, and then I'm going to start just kind of following my arrows. I know they're already drawn, but the first terms being multiplied is the x times the x, right? So you keep and you add the exponents, you get x squared. Then we have x times 1, which is just like x times 1 is just 1x. I just write x. I don't write that little one. And then we do the inside terms, which is this 1 and that x, which is going to be another 1x. And then 1 times 1 is 1. Signs are the same, so it's positive. Right here, these are the same. And so what happens is we have 9 plus x squared equals x squared. X plus x, whenever you add or subtract variables, what you do is you like do math on their numbers and then you keep and keep. So 1x plus 1x is just 2x. Okay. And then we have that plus 1 right here on the end. So now I need to actually start moving things over to one side so that I can solve. I'm going to show y'all what's going to get moved. On the right-hand side, right, I want to move pretty much everything to the left-hand side. So it can be set equal to 0, and I can see like kind of what I'm working with. So this x squared, I need to move it, which is the opposite. I need to move this, which is the opposite, and I need to move this. Every single thing, I'm going to be moving it to the left-hand side. Okay, now let me just I'm going to kind of just for space, just to be completely honest with y'all, I'm going to write everything in purple. I'm going to write it in black on the left-hand side, but hopefully it makes sense to y'all. Every single thing is being moved. So on the right, all I'm going to have is a 0, right? So I have 9 plus x squared minus x squared minus 2x minus 1 equals 0, because all of those canceled. And then do y'all see on the left-hand side, now I have everything. And when I go through there and I look, I notice that I have a plus x squared and a minus x squared. Okay, those are those additive inverses. They're the exact same thing with different signs. And so they end up canceling, right? And then that minus 2x, there's nothing like it. There's absolutely nothing on that left-hand side that just has an x. So it's just going to stay. But the 9 and the 1, those are just numbers. We can combine those together. And if you look at 9 minus 1, don't you just get 8 minus 2x equal 0? And that was because these two right here could be combined together. That's where I got that 8. These problems are always way more complicated than they need to be. Pretty sure I just like copy and paste from y'all's homework. So hopefully if you have this in front of you and it's all filled out, like you can do your homework. Okay, y'all, I'm gonna rewrite this 8 minus 2x over here, so I have some more room to write. And then it's proper, better, the way it's supposed to be written. If you put the variable in the front, because usually it goes like variable squared, variable to the first power, no variable. So I'm gonna kind of rewrite these like this. I'm trying to think, because there's like 3 different ways I can go about this. I don't really like my notes that much. So if I do this, let's just say that that step may have been able to be avoided, because either way it'd be fine. I am going to go against my notes right here though. Our goal is to solve for this x and to see what this unknown is, so I could figure out both of the legs that they didn't tell me about. So if we just kind of solve for this x here, I would move my -8. I'm sorry, my -8. I'd move the +8, which would end up being negative on both sides. -2x, that goes away, equals -8. And then I'll just solve for your x. We would do what? Divide by -2. I'm trying to figure out why I did completely different step last semester. And then we have x equals 8 divided by 2 is 4. Signs are the same. So that quotient, or like the answer to that division problem, would be 4. This right here is this side, right? Because we have x equals 4. I'm trying to highlight that. And this is where we have that x. So one of the unknown legs is 4. The other unknown leg, which is this one right here, is going to actually be what? 5? Does that make sense? Yes, don't just say yes. Tell me if it doesn't. Okay, so we have the 3 was one of the ones that they just gave us. The x is the first unknown. The x plus 1 is because they were just consecutive integers, not consecutive even, just consecutive. When you count consecutively without even thinking about it. 1, 2, 3, 4, 5, 6. You just keep adding 1. Okay, and you go through all of that hot mess of steps to get to what is x. What was that first unknown that I didn't have the value to yet? Okay, well, I just answered it right here, x equals 4. Then it's like, look, there's an x, that one's 4. The way you figure out the other one is the x plus 1. Well, if x is 4, 4 plus 1 is what? 5. Okay, so that's how you do that problem right there. It's really just making you create all of these different types of quadratic equations, tons of distribution, tons of moving things around. And then once you solve for the unknown, you kind of have to plug it back in to whatever you were trying to figure out in the first place. Okay. Okay. And if you ever get any kind of negative answer, just remember that like length cannot be negative. I can't say that I live negative 27 miles away from the nearest Chick-fil-A. I really think that's actually true too. It's pretty sad. Okay. Okay, let's do 6, 7, and 8. For problem 6. Okay, it says solve the following. The length of each side of a square is 3 inches more than the length of each side of another smaller square. The sum of the areas of the square is 117 inches squared. Find the length of the 2 squares. Okay, so for that problem we did with the even consecutive integers, we knew that there was 2 things, and we let one equal x, and that was just an unknown. And then we used that value that we didn't know, and the fact that the next unknown integer was consecutive and we added 2 to it, right? And so basically you're just like using the first unknown and then figuring out how it's comparing to it to explain the second unknown. So here I have 2 squares. I have a smaller square and then I have a square that's 3 more inches. So my smaller square is the first unknown, which is always my x. The second square is going to be the same size of the smaller one, but then 3 more inches. So more is like you're adding. So we have x and then we have x plus 3. That's the first square, the second square. And then right here where it says is 117, that's equal 117. Okay, so all these little words kind of go into play to figure things out. Let me write down what I just said here though. We're going to let smaller square be just simple x. And larger square be x plus 3. And this is why if you read the thing, it says the length of each side of a square is 3 inches more than the length of another smaller. That's why I did the plus 3. Okay. Now you don't ever start with the bigger. You'll always start with the smaller. So I just knew that something's bigger than the other. Let the smallest one be x. The other one represent that plus 3. Then it says the sum. Does anybody want to tell me what sum means in math? Add. It's telling me the sum of these 2 squares. So I'm going to actually write down the smaller, how I'm representing it, add to it the bigger, and then it says is, which is equal 117. Okay, and then you go through there and you actually mess with it. The only thing is, let me just read this. So hold on. The sum of, so I'm going to do the add. I'm trying to see. I didn't write it on here why. The length of each side. Find the length of the 2 squares. Okay. So I'm not seeing where it says on here it's being squared other than the inches are being squared, but I know that the measurements of a square are squared. So I'm going to write this. If it doesn't make sense, y'all tell me, but the first actual measurement of the square that's smaller is going to be the x. And then you're going to square it and add to it the measurement of the other square, which is the x plus 3 in parentheses, and square that, set it equal to 117. And then this is the actual equation that we solve. Each side squares 3 inches longer. Okay, so then we just FOIL. So I'm just gonna FOIL it, and if I do it wrong, y'all tell me, and if it doesn't make sense, y'all tell me. But if I do x times x, I get x squared. X times 3 is 3x, another x times 3 is 3x, which would be 6x, and then 3 times 3 is 9, equals 117. Instead of writing the parenthesis twice and doing the arrows, I just said it out loud, kind of did it in my head. And then I noticed that both of these are squared variables. So they actually can be combined together. And what you do is you add their numbers, keep the variable, keep the exponent. And then I have the plus 6x plus 9. This 117 needs to be moved. And if you didn't move it until the next step, it'd be fine. Like if you're going that way, where you're probably fine. I start running out of room and I'm like, okay, I know it has to be moved. So I kind of just did it in one step right there. And then what I noticed is the positive 9 and the negative 117. 2x squared plus 6x. You would grab your calculator, always put the positive in first. 9 minus 117 is a negative 108 equals 0. This example ends up having, well, I mean, there's multiple things you can do. If you notice that that A is not the number 1 and you do the quadratic formula, that's fine. But what I noticed, because I try to avoid that thing sometimes at all costs because the shortcut is easier in my mind. 2 right here that's leading in the front. And then I have a 6 right here in the middle. And then I have that negative 108. If you just look at the numbers, 2, 6, and 108, they're all even, right? They all can be divided by 2. So what I do is I actually divide all of them by 2, and that creates that leading coefficient to be a 1, and then I could do that shortcut. Okay, but if you saw that this was a quadratic and A is not 1 and you did the quadratic formula, it's okay. You're still going to end up getting the same answer that I get. Okay. So actually, this is what I was saying. This is 0. Oh, right here. Now, if I divide the whole entire left-hand side by 2, I get x squared plus 3x. And then 108 divided by 2 is 54. Signs are different, so it's a negative 54 equal 0. And then I noticed that I kind of just on purpose created a shortcut. I'm working with the variable x. Here I can think about the number 54. And I want 2 numbers that multiply together to give me 54 and can either have a difference of or be combined to give me 3. How much room do I need? I'm going to scoot over right here, y'all. And so if I take 54, I know 1 and 54, and then I have 2 and 27, 3 and 18, and 6 and 9, all whole numbers. I wouldn't put 4 in there because if I do 54 divided by 4, I get 13 and a half. That's not written on this little factor tree, okay? Now, the 2 numbers that would multiply together to give me 54 and at the exact same time combine together to give me a positive 3, that's going to be the 6 and the 9. If I want my 3 to be positive, which number is going to be positive, the 6 or the 9? 9, and then my 6 will be negative. That's going to be the combination that works out to give me that positive 3. And so what I have right here is 6 and 9. It's negative 6, positive 9. I've gotten to a point to where I've created those linear factors. And what I can do is actually set them both equal to 0 to solve. Here I get x equals 6. And right here I get x equals negative 9. After a while, you forget what problem you're even freaking working on. The squares. Okay, and as actually finding the length of the 2 squares right here. Length. Can I even spell it? There we go. Length cannot be negative. Okay, so this one cannot be an answer. The x equals 6, that can be an answer. And x was what? X was my smaller triangle, right? So it's really hard to write right now, but I'm trying to write right here, smaller. I just said triangle, I'm sorry. Smaller square is 6 inches. And the larger one the larger square. How did I have the larger square defined? X plus 3. If x equals 6, my larger square is actually 9 inches. But it is filled, so very much filled with knowing how to distribute, understanding that we're dealing with quadratics in 1.5. There's many different forms of quadratics, moving things. Then when you get to an answer, just to be honest with you, that's not your answer, right? Because it started so like abstract without really telling you anything that you had to create these unknowns. Let something be an x, let something be an x plus 3. You do all this work. All you figure out is what x is. You got to plug it into these little bitty expressions to actually get their final answer. Okay. So if you start getting to the bottom and you know for a fact you factored right and you did everything here correctly, and it keeps telling you that your answers are wrong, it's going to end up being because you're not plugging it into how the problem started. But you could just ask me a question. Okay. We have 2 more problems left. Okay. That's what I'm saying too. Y'all, if I ever type something up, it's because I don't want to write any of it. And yeah, if I'm writing it, that's when I'm like, hey, I like this area or this section, this material. Pass outs are for me copying and pasting homeworks because it just requires too much work and words that come out of my mouth. Okay. The area of a square is 32 more than its perimeter. Find the length of a square. Okay. So the area of a square is actually found by doing a squared. And then okay, here's the area of a square. Here's a square, right? So these are all sides of a square. Area is taking a squared. That's what I didn't write a second ago, but that's why we squared both the x and the x plus 3. Okay, because that's how you find the area right there. And then for a perimeter, just like if you create like a fence or something, you would count all the sides, you would add them all up. So if we have A, the perimeter would actually equal 4 times A. And so here it says the area of a square, right? So that's the area. Why am I still in green? The area of a square. And it says is, that's our equal sign. And it says 32 more than its perimeter. And you always want to write the variable first. That's the perimeter. 32 more means to add 32. It's not even giving me units of measurement. That's kind of why I paused when I was reading it. But this would be saying that the area of a square is 32 more than its perimeter. If you wrote it with the 32 in front, that's okay. I always just try to write it. You want the number that doesn't have a variable always at the end. It's just like more proper. Okay. Now for me to actually solve this, I need to move things around, get it set equal to 0. And then because it's A, is a 1, then we could do a shortcut. Okay. So if I move this, I also need to move this. I have A squared minus 4A minus 32 equals 0. The coefficient or the number in the very, very front is this invisible 1. That's why I can do this shortcut. So it's the exact same thing that we've done on the last couple of problems. The only difference here, I always do these parentheses and then I almost immediately throw those X's in, right? Here, I'm working with the variable A. So I'm going to do A's right here. And if I used A's on the note, I'm assuming like they use A's on the homework. And so that might be why I did that. Because you could use whatever, but okay. Now, if I think about the numbers that multiply together to give me 32 and then combine together to give me a 4 that's negative, So 32, I have 1 and 32. What is that? 2 and 16. And then 4 and 8. I believe that's it, right? Okay, that's what I was thinking. So 1 and 32, that would never work. The 2 and 16, they would multiply to give me that 32, but I couldn't combine those together to get to a 4. That's negative. I noticed right here with the 4 and the 8, they will actually end up being the numbers. I'm trying to think. If I combine those together and I wanted the outcome to be negative, I would want the larger one to be negative. So I have a 4, I have an 8. The 8 is negative, the 4 is positive. I have created linear factors, which means I now have the ability to actually set them each equal to 0. And to solve them, here I get a equals -4. But I know that this is basically length, right? Yes, this is length, which cannot be negative. Over here, I get a equals 8. And that would be it. Because the question itself just says to find the length of a side. So what this is saying is my triangle actually looks, why do I keep saying triangle, Jennifer Nicole? My square actually looks like that. Because all of the sides are the side that we found for, which is 8. I think there's 6 or 8 problems on this homework. So there's not a ton. Okay. Hopefully a lot of them are just gonna end up being set up. And then 2 ended up being crazy that I hadn't really seen before. And so I think those are the ones I ended up deleting. 8, 9, 15. Okay, let's do this last problem. Okay. It says, at a point on the ground, 80 feet from the base of a tree, the distance to the top of the tree is 11 feet more than 2 times the height of the tree. Find the height of the tree. Okay, so what we would do, because this is 1.5 and we're dealing with quadratic and Pythagorean theorem, go ahead and draw a triangle. And the legs represent the length on the ground and the height of the tree. Okay, so this is going to actually be the height of the tree. And it says at a point on a ground 80 feet from the base. Okay, this is like your ground. The height is going to be the actual height of the tree. And then on the ground, we're 80 feet away. And then that hypotenuse is going to be the distance from the top of the tree. And so it says the distance to the top of the tree is 11 feet more than 2 times the height. So 2 times the height and 11 feet more. At a point on the ground. Let me see if there's a way to make this visual. There's not really a way. I wanted to draw a tree. This is your tree. That's a beautiful tree. Okay. This is the point on the ground that they're talking about. So at a point on the ground, 80 feet from the base of the tree, the distance to the top of the tree. And this is what they're telling us. The distance from the top of the tree from that point is 2 times the height, and 11 feet more than the height of the tree. So that's kind of what's happening there. It's just hard to really draw that. I needed a brown. But I was able to just set up the little right triangle. And then now we would use the Pythagorean theorem to figure out what the actual height of the tree is. And so whenever I do this, I just want to make sure. Like I have this as my A. This is my B. This is my C. And the Pythagorean theorem is A squared plus B squared equals C squared. My A is going to be the height, which is H, and it's going to be squared. Then I'm going to add to that my B, which is 80, and then it's going to be squared. Then I'm going to add to that my C. Because this is going to be squared, I need to put it into parentheses because it's a binomial. And then I'm going to square it. And then we're actually going to do all of this and then have to put it into the actual quadratic formula because it ends up just being really big, huge numbers. Okay, so if we have H squared plus, if you grab your calculator, you do 80 and then you hit that square button, it'll give you 6,400 equals. If I make a copy of this, I get 2H plus 11 close, open 2H plus 11 close. These numbers are fairly large, so I'm trying to actually do each step here instead of just doing it in my head. We're going to do the 2H times the 2H, right? First, I'm writing down the left-hand side. Okay, 2H times 2H. You multiply the numbers, then look at the variables. 2 times 2 is 4. Those signs are the same, so it's a positive 4. And then you keep your variable and you add the exponent. So you actually end up getting 4H squared. And then what you do is you take the 2H and you multiply it to the 11. And so 2 times 11 is 22. And then the 2 has an H, so your 22 has an H. 22 times 11 is 22, and then don't forget that variable. It's positive. This, for your inside terms, is the same multiplication. You end up getting another positive 22H. And then on the very end, what I end up doing is multiplying 11 times 11, which is 121. I'm actually going to move the values from the left-hand side to the right-hand side. The first one I would move is going to be this H squared. You do the opposite, so it'd be a negative H squared. On the left-hand side, it goes away. I'm only left with 6,400 equal 4H squareds minus 1H squareds is 3H squared left. Plus, look right here. We can go ahead and combine these together, right? The positive 22 H's. I would add their numbers together, which is 44, and then keep their variable and keep their exponent. That exponent only changes when you do multiplication or division. And then I have the positive 121. Now I'm going to move the 6,400. I make sure that I like put it underneath that 121 because those are the only ones that are just numerical values. Left-hand side cancels, becomes 0 equals 3H squared plus 44H. You grab your calculator, you always put the positive 1 in first. So you do 121 minus 6,400 and you get negative 6,279. Y'all, even if that first number was a 1, I would never try to do that shortcut method here where you factor that C, because nobody wants to factor 6,279, right? But because the first leading coefficient right here isn't 1, it's a 3, we would actually need to go ahead and do the quadratic formula. And so I actually have that right here. We need to figure out what our A is, what our B is, and what our C is. My A, because it's in this form, right? AX squared plus BX plus C, that's the form. And here my A is 3. My B is 44. And then my C is a negative 6,279. Okay, that leading coefficient isn't 1, but even if it was, I'm not fixing to factor that 6,279 by myself. I'm gonna do the quadratic formula. These are actual quadratic modelings of real life problems. That's why we have to keep doing all this stuff. Okay, the quadratic formula is going to be, it's x equals and then the actual quadratic formula. I'm trying to think. Yes, what happened? Oh, I don't know which one that is. Oh, this one. It tries, I don't even have to click it. I just have to do that. Okay, so here, the variable that I'm looking for is an h because it's representing our height. So we're actually going to have h equals, and that's the only one that changes. Everything else, whenever you actually do the quadratic formula, will stay the same as far as the A, the B, and the C. But to be proper, we are looking for the height, and so it is our unknown. I just apparently saw that on the homework it wanted h equals, so that's why I set it up this way. So we do h equals, I have this long fraction bar. I have a negative sign, which is fixed. I know I always have to write it. Then it tells me to enter B. My B is 44 plus or minus the square root of, and this is, can't remember when we did this. Okay, and then we have B squared. So I have 44 squared, a negative sign, which is fixed. I always write it. A number, which is fixed. I always write it. And then times A, which is 3. And then times C, which is a negative 6,279. I extend my fraction bar out, and then I go ahead and close like the roof to that radical. The denominator, I have 2 times A, which is 3. And pretty much cover up everything except for this. Hopefully I'll have everything written. H is equal to large fraction bar. I have negative 44 plus or minus the square root of, I grab my calculator, I do 4. I hit the button that shows x squared, I hit enter, I get 1,936. And then I do the multiplication of 4 with 3 and 6,279. I get 75348. And right here, I notice that I have 2 negatives. So negative times a negative is a positive. And then I just make sure that that fraction bar stays under every single thing in the numerator. 2 times 3 is 6. So the height of this tree is equal to fraction bar negative 44 plus or minus the square root of. I grab my calculator and I add both of those numbers underneath that radical, and I get 77284. Close the roof. 6 is my denominator. the height is equal to, I do a fraction bar, I have -44 plus or minus. On my calculator, if I hit the second button and then the squared root button, it creates a radical. I'm gonna go ahead and put this whole number underneath it and see if it's a perfect square. Okay, because again, I also would not want to do that prime factorization with the upside down V's and like factor all that out. Even though these end up looking really ugly, when you put this in your calculator, it is a perfect square. It actually ends up equaling 278. And then denominator 6. And then here, because of this symbol right there in the middle, it's telling me that I actually have two different answers. Okay, so the first one is going to be h equals, we have our fraction bar, -44, let's do plus 278 over 6. Okay, or we have the x equals fraction bar, -44 minus 278 over 6. I didn't even finish this one. I'll just tell y'all what the answer is. Okay, if I got my calculator and I put the positive in first, the 278, then subtracted the 44, and then after I hit enter, I divided it by 6, I end up getting 39. And then over here, I get h is equal to, those signs are the same in the numerator, they're both negative. So what I did was I just added them together. I kept their negative sign. And then after I hit enter, I divided by 6 and I got -54. But this whole entire problem was to try to figure out what the height of the tree was. And I know for a fact that height cannot be negative. And so it was 39 feet tall. So just if you create the tree problem, if it asks you like in words, right? This is going to be the height of the tree. This is your ground. And then the hypotenuse is the one that ends up giving you that really very weirdly worded expression. 2 times the height plus something, okay? If there's one on the homework that ends up giving you a picture, the one I couldn't draw on here, usually it kind of makes a little bit more sense when you see the picture. If not, y'all just ask questions. That's it, y'all. So many quadratic equations, just over and over and over and over again. Good luck on your speech, Nick. Can't even hear me. Bye, y'all. Mm-hmm. Yes, what would it be for? And then like, when would you even take it? You know what I mean? Like, that would be the thing.
So, but I never thought that it was like the weather was gonna be like this.
Oh, I know.
And almost birthday's like tomorrow, but we planned it for this weekend. We didn't plan to come back till next Tuesday.
Where y'all going?
Houston.
Okay, just email me and we'll figure something out.
Okay.
Okay?
Yeah. Ria, you want some money?
Yes, I want money.
I just bring it. Okay. Yeah.